So in this question, we are given the electron in the spin state, right? So we have chi that is equal to a 1 negative 2i and 2, right? So there are four parts that we are required to solve over here. The first part is that we have to determine the constant a by normalizing chi, right? So let's start with this part's solution, right? So we have the electron in spin state that is given in the equation, right? So let's say that this is equation 1. Now what we are going to do is that we are required to find out the constant. So for that we are going to set that the absolute value of chi square is equal to 1, right? So now we are going to find out the value of a. So we have the absolute value of a square times parenthesis 5 plus 4 that is equal to 9, that is equal to 9 a square that is equal to 1, right? So when we'll solve it for a, we would get that a is equal to 1 divided by 3, right? So this is a solution for part a, right? It was very simple. We just needed to find out the value of a by normalizing chi, right? So we just did that in the beginning and then we simply found out the value of a. Now the next part is that the next part is that if we measured the s sub z on this electron, right? So it asks us that what values would we get and what would be the probability of each um, value, right? So along with that, it asks us that what would be the expectation value of s sub z, right? So let's start with it, right? So first of all, we need to find out the value of s sub z. So for that, we need to write chi as a linear combination, right? So let's start with that. We need to write it as a linear combination of the eigenspinors of SC. So we had chi is equal to A10 plus B01, right? So now what we are going to do is that we are going to compare this equation with the given equation, that was equation number 1, so that we get that chi is equal to 1 negative 2 times I divided by 3, 1 0 plus 2 divided by 3, 0 1, right? So these are the possible value. So now what we are going to do is that we are going to find out the possible values of s z, right? So the possible values of s z would be h cross divided by 2 and negative h cross divided by 2, right? And the probabilities for these values would be parenthesis 1 negative 2 um, I divided by 3 square, sorry, 3 absolute value square. So that would be equal to 5 by 9 and 4 by 9, right? So this is the possible value of SZ, right, along with its possibility, and this is the other possible value of SZ along with its possibility. Now we need to find out the expectation value of SZ, right? So for that we are going to use the equation that is S sub Z is equal to chi raised to power t, and S sub z chi, right? So for that we need to write down the values of x sub t, right? So over in this case x sub t is equal to 1 divided by 9, 1 plus 2 I and 2, right? Now the next step is that the value of SZ is the one, um, right? So S sub Z is equal to H cross divided by 2, 1, 0, 0, negative 1, right? And chi is that is actually given. So that is 1, negative 2i and 2, right? So what we are going to do from here is that we are going to plug in all of these values of x, t, s sub z and x over here, right? The equation that we just wrote for s, expectation value of s sub z, right? So when you plug them in and you'll do a little bit of um, mathematics, right? It's very simple. No technical thing is involved over here in this mathematics, right? So you just need to simplify it and you will get that the expectation value of s sub z would be equal to s cross divided by 18 parenthesis 5 negative 4, right? So this would be equal to h cross divided by 18, right? So this is the solution for part B, right, along with these possibilities and possible values of S sub Z, right? Next part is that if we measure Sx on this electron, right? Similarly, we need to measure S sub x on this electron, right? So we need to find out its possible values, the probabilities, and what would be the expectation value of x, right? So let's start with it, right? So now again we need to write it as a um, linear combination, right? So s sub x is equal to h cross divided by 2 0 1 1 0, fine. So now we need to find out the eigenvalues of this operator. So we would find out by writing negative lambda negative h cross divided by 2, positive h cross divided by 2 and negative lambda, right? So this would be equal to lambda square negative a square divided by 4, that is equal to 0, right? So from here we conclude that the value of lambda would be equal to plus minus h divided by 2, right? So from here what we are going to do is that we are going to solve the equation to find the eigenspinors. Um, so we would have h cross divided by 2 0 negative 1 1 0 um, alpha beta is equal to plus minus h cross divided by 2 alpha beta, right? So now we would write an equation for chi positive raised to power x, right? So chi positive raised to power x, so that would be equal to 1 divided by under root 2 1 1, right? And the other would be chi negative x raised to power x, so that would be 1 negative 1 over under root 2 1 negative 1, right? So let's say that this is equation 2. Right now, what we are going to do from here is that we are going to write down the eigenspinors of s sub x in the following form, right? So a chi is equal to under root 2 divided by 3 square bracket a 1 1 plus b negative, sorry, positive negative 1, right? So we need to find out the values of these constants a and b. So we would set this equation equal to 1, right? So you would have a plus b is equal to 1 negative 2i, right? And the other would be a negative b is equal to 2. Now we have these two equations, right? So we would solve them simultaneously to find out the values of a and b. So the value of a, it would be 3 by 2 negative I, and the value of b would be negative 1 by 2 negative I, right? So now what we are going to do is that we are going to plug these values um, back over here, right? So that we have chi is equal to under root 2 divided by 3 divided by 2 negative I 1 1 plus negative 1 divided by 2 negative I positive 1 negative 1 square bracket closes, right? So from here what we are going to do is that according to this equation the possible values of um, h cross 2 divided by 2 with the probability um, under root 2 divided by 3 3 divided by 2 negative I square, so right, that would be equal to 13 by 18, and the probability of negative a divided by 2 would be 5 by 18, right? So this is the solution for part this is the half solution for part b, right? So this is one possible value and this is the other possible value. This is the probability of the first possible value and this is the probability of the second possible value. Now the next step is that we need to find out the expectation value, right? S sub x that is equal to chi t s sub z chi, right? So what you're going to do is that similarly that we are going to follow the same procedure that we did for S sub z, right? So you would be following that, and that's very simple. I'm not going to do it again, right? You can do it by your on your own, and when you will simplify it, you will get that the expectation value of S sub x is equal to 2h cross divided by 9, right? So this is the solution for part b, sorry, part c, right? Complete solution for part c. Now the last part, that is a t part, is that we need to find out the value of s sub y along with its probability, right, and the expectation value of s sub y, right? So in this part, we will follow the same method as we did in part C, right, to find the eigenvalues and their probabilities. I'm just going to write down the basic equation. You can do the math yourself. So we have chi is equal to under root 2 divided by 3 square bracket 1 divided by 2 negative 2 times I 1 I positive 1 divided by 2 1 negative I, right? So from here we will find out the possible values, that would be h cross 2 divided by h cross divided by 2, right? And its possible probability is 17 divided by 18, and the other possible value would be h cross divided by 2 negative h cross divided by 2, and its probability would be 1 divided by 18, right? So this is the half solution for part D. Now the last thing that we are required to find out is the expectation value of S y, right? So for that we would be using the equation that 1 over 9 1 plus 2 I times 2 h cross divided by 2 0 negative I positive I 0 1 negative 2I 2, right? Solve them and we would get that the expectation value of S y is equal to 4h cross divided by 9, right? So this is the complete solution for part